All right, let's begin the demonstration of the week 5 challenge and participation activities. I will be covering the ones that involve all of the challenge activities and the participation activities from the week 5 or module 5 assignment that involves calculation. So without further ado, let's go ahead and get started. The first one I'm going to address is the challenge activity 5.1.1, where we are identifying H sub 0, which is the null hypothesis, and then H sub 1 or H sub A, depending on what textbook or resource that you're looking at, the alternative hypothesis. When I read this statement, it says the librarian believes the most books are kept longer or shorter. Longer or shorter is a difference relationship, either being different or not different. Different versus not different is going to be an equals, not equals relationship. So we start out, and I'm actually going to work this from bottom up. The null hypothesis is that it was kept for 3 weeks. So the null hypothesis, I'm going to, after I start this, is going to be that it was kept for 3 weeks versus that it was not kept, that it differed from 3 weeks. So I'm going to select differ from 3 weeks, check the answer, and notice we've got the correct answer on the first challenge activity. On to the next challenge activity, 5.1.2, identifying sample statistics and population parameters. We need to identify in this particular case what is the sample statistic as well as the population parameter. The way that you keep these straight, notice population parameter, they both start with the letter P. So a population yields a parameter. Sample statistic, they both start with S. So sample and statistic, you're dealing with both of them being S. So that's how you tell the difference between the two. Now, from a sample statistic, the sample is based off of the 150 random select visitors with the mean time of 28. So the mean from the sample is 28. So the sample, I'm going to select the 28 minutes. The population parameter, unfortunately, we do not know that information. So relative to the information that was given to us in the context of the original problem, we'll check that, and we've got that correct in that instance. Let's go to the next one. Same song, different verse. Sample statistic, it says a region receives a mean of 0.8 inches of rain per day. Local weather forecast believes the region receives significantly more than the expected amount of 0.6. So the region, that was what was observed. So that came from the sample that was observed in that case, which is 0.8. Relative to the information that's presented here, we do not know what that given population parameter is. So I'm going to select unknown on that one, check it, and notice I've got the correct answer on that one. Going to the last one on this here. In this instance, again, the 81% comes off the sample. The 86, that's the belief that you would do relative to the null versus the alternative hypothesis. So I'm selecting 81% out of the sample statistic. However, we do not know what the population parameter is going to yield. So that's going to be unknown in that instance. Check it. And we've got our 5.1.2 challenge activity completed. Let's go to 5.2.1, the intelligence quotient participation activity. This will require some calculations, so I am working a participation activity in this instance. So in this particular case, we are given that the mean is 100 in this instance. So what does the hypothesis mean? Based off of the statistically higher than 100, our mean in this case is going to be 100. We check it. We've got the correct answer. Now, let me get my pen active here. Here we go. Okay, in the context of the problem, we need to determine whether this is a two-tailed test, a left-tailed, or a right-tailed. Two-tailed is going to be that equal, not equal relationship, or i.e. that it is different than the hypothesis mean. If it's less-tailed, that's going to be a lower, less than relationship. If it's a right-tailed, it's going to be a greater than or a higher relationship. If you look at the context of the problem, it says statistically higher. That statistically higher is going to tell me that it is a right-tailed test in this instance. So I'm going to type in the word right-tailed as instructed there, check it, and we've got our correct answer. Now I'm going to clear my markings here. We do need some information to do the calculation on the test statistic. So I'm going to say test statistic. There are some components that we need to calculate the test statistic. The first of which, I'm going to start out with an equals and a parentheses. What is the observed value? Well, the observed value on this guy is 105. So the 105 is coming off of the sample of the 36 students. So the observed value is going to be 105. I'm going to subtract that off the hypothesized mean, which is 100, close the parenthesis, do a division. I'm going to open up another parenthesis in this instance. From here, I need to know what the standard deviation is. The population standard deviation is 15. So I'm going to key in 15, do another division. And what is my sample size? Is 36. I have to apply the square root, which we've talked about in the previous ZyBook assignments. The SQRT represents square root of 36. Close the parenthesis twice. And you'll notice we come up with the test statistic as 2. So we're going to do a 2 there, check it. And we've got our correct answer. How do I find the p-value? P-value needs to be calculated. We're utilizing Excel to accomplish this. P-value is going to start with this formula. You're going to start with an equals, a 1 minus, and we're going to use like what we did back in week 4 using norm distribution. Norm distribution off of what? Based off of the test statistic, 2, comma, mean is going to be 0, standard deviation of 1. The fourth parameter is a true there. Close your parentheses, we end up with 0.02275. Now you'll notice over here, they want this as 3 decimal places. So I have to come back up to the formula. I'm going to round it to 3 decimal places. We did this back in week 4, where we showed how to do a round inside of Excel. That gets me 0.023, 0.023, check it, and we've got our correct answer. Now, need to do a visual here to show you what's going on relative to whether we reject or fail to reject. So I'm going to draw a line here. Inside the problem, it tells us this alpha, which is the level of significance. The level of significance is 0.05. Now, from a p-value perspective, if the value is less than 0.05, we reject the null hypothesis. If it's greater than 0.05 or whatever that level of significance is given to you inside the problem, we do what I call an FTR, fail to reject. For our value here, the 0.023 resides here. This is, if you look at from a number line perspective, 0.023. We are rejecting the null hypothesis. So the question is, should the null hypothesis be rejected? We identified that it was rejected. Therefore, I'm going to type in the word yes, check it, and we have the correct answer in this particular case, completing that problem. Next one we got to deal with here is, let me show the problem number. Yeah, 5.2.2 exam scores. They have already done all of the calculations for you. So we're going to use this chart to help analyze our respective answers on the problem. So the first thing is, where does the null hypothesis or H sub 0 obtain from? That is going to be off of the hypothesized mean. So it's going to come off of that guy right there. Greek symbol mu represents the hypothesis mean. So we're doing it off of that mean. So we've got our 83 there. The second question, we have to analyze what is given inside the context of the problem. In this case, sufficient evidence that the mean score of the class is lower than, keyword lower than, is going to be a less than relationship. So on the alternative hypothesis, we are going to utilize the less than symbol to analyze that. So relative to that inside the problem is what tells me that is the less than relationship. P-value, change the color here. P-value, since it is a lower than, this is a one-tailed test. So less than or greater than is one-tailed test. Two-tailed test is either an equals, not equal to relationship. So since it is a one-tailed test, I have to pull the p-value relative to a one-tailed test. And in this case, if I look at 0.040966, they want this guy as 3 decimal places. So I'm looking at that, using that 9 to round up. So that 0 is going to become a 1, so 0.041 in this instance. So I'm utilizing that to get that answer. And then our last piece, we're going to use this p-value we just came up with relative to the level of significance that was given to us inside the problem. So if I come over here, number line, similar to the previous one that we just did, level of significance, or alpha, is 0.05. Where did I get that? I got that from right there inside the problem. With any p-value, if it is greater than that value, we are going to fail to reject the null hypothesis. If it's less than that, we reject it. So if I come over here, change the color, my p-value that was obtained was this 0.041. So 0.041 is going to sit in the rejection region. So if I come down here, I'm going to select reject the null hypothesis, and notice I have this problem complete. Going on to the next exercise challenge activity 5.2.1, hypothesis test for a population mean. Again, they've already done all the calculations, so we're going to utilize this. This guy looks similar or approximately normal in terms of the weight. So we're going to use that actually here later on when we do the respective calculations. So population parameter, that's going to be based off of all of the eggs off the farm. The sample statistic comes off of the 500 eggs, based off the mean weight of the 500 eggs that are listed there. Does this meet t-distribution? This does look yes, and it looks to be approximately normal. It's not fully normal, but the behavior of that curve kind of looks like it is bell-shaped in that instance. So we'll check that, and we've got everything good to go on that first problem. Let's take a look at the second one. The alternative, let's deal with null hypothesis. When dealing with the mean, you're always utilizing off of this guy right here, the hypothesis mean. So if I read the statement, I got to make the determination whether it's an equal, not equal relationship or a less than, greater than relationship. So based upon the reading of this up here, it says university claims that a student can expect to spend a mean of 3 hours a week per homework for every credit hour class. The administration believes that it's no longer correct at the alpha 0.05 in the sample of 300. So administration claims it's different, that it's not equal to it. So it is an equals, not equals relationship. For these, null versus alternative, the way that ZyBook lists this up is you start with null and then the alternative. Null is going to match that equal relationship. So I'm actually going to select that one as an equals. In this instance, on the alternative, it's going to be not equal to it. Check it, and we're good to go on that problem. And let me clear out my markings. Let's go to the last one here. Okay. So for the t-statistic is given to us inside the chart. We do not need to use Excel, but we are going to have to do some rounding on this guy. So we've got in our t-statistic, they want this as 4 decimal places. So you'll notice the 9543 that's listed there. So 1.611. In this case, we'll just pull the 4 digits off that guy. So we're going to do a 1.611 p-value. In this instance, we have to determine whether we're going to use the 1-tail or the 2-tail in this particular instance. Again, that's told by the reading of the original statement. It says major retailer promised 2-day shipping on certain online orders. The consumer advocacy believes that the shipping times are longer. Longer is going to be a 1-tailed test. And they actually, inside the graph here, kind of leads that to believe that it is a 1-tailed test. So you're pulling it off of that guy right there. And we need 4 decimal places. So 0.5389 is going to round that up to 9. So we're going to use 0.0539 here. 0539. All right. So now we have to compare relative to our number line that we've done here earlier inside the presentation. I'm going to draw a line. Level significance was given to us as 0.05. Again, in analyzing p-values, if it's greater than the level of significance, you are in the fail to reject region. If it is less than that, you are in the rejection region. In this instance, your value 0.0539 sits to the right of the level of significance. This is where 0539 resides. Hence, you are in the fail to reject region. So in this case, since the p-value is greater than it, we are going to fail to reject. And sufficient evidence, here's the deal. If, and I'm going to write this down so that you've got this as a reference. If you reject the null hypothesis, there is sufficient evidence. If you fail to reject the null hypothesis, there is not sufficient evidence. So when I select this off, that sufficient evidence does not exist for mean greater than 2 days. If you had a p-value less than 0.05 relative to the level of significance they gave you, then you would have said it does exist in that case from a sufficient evidence perspective. Check it, and we're good to go with that challenge activity. For this next piece, we need to utilize the download of this Excel spreadsheet. So I'm going to do a click to this. And however it shows up inside your browser, Firefox, Chrome, etc., go ahead and open up that guy. So I'm going to do this behind the scenes. Just a second. There we go. If this comes up with enable editing inside of Excel, do that. And I'm going to bring this back over and bring this off to the right. There we go. And I'm going to bring ZyBook up there. There we go. Now we're good to go with this here. Okay, so this first one says use sheet 1. Sheet 1 is this going to be this worksheet or tab that's listed there. We need to come up with some information in this case. Sample size is greater than 30. So by central limit theorem, it is approximately normal. We can select yes on it. Now, utilizing sheet 1, X bar is going to be the mean or the average. So I have to calculate the corresponding mean or average. I'm going to come over here, going to do an equals, do an average. That's going to get me the average from anything inside of column A, because I need to use all of the values that are inside of column A there. Easiest way to do that, if you do an A colon A, that is going to pull all of the values that come from column A in that instance. We now have the mean as 2.75. Now, they want 3 decimal places on this. So I am going to expand, if I can get this up here. Seconds. Here we go. I am going to increase that value. So I need to increase the decimal place. So I'm going to do that by, on your ribbon here, increase it by 1. That way now I've got it to 2.752. Bring that back over here. So now I've got my mean as 2.752. The t statistic, let's type in a couple things here. So the hypothesized, I'm just going to abbreviate, mean was given to us as 2.75. I also need n, which is the sample size, which is 50. And let's see here. I think I have everything that I need. Okay, so to get the t value or the t statistic, we start with an equals. It is the observed value. That was the 2.752. I do need to put a parenthesis at the beginning there. minus the hypothesized mean, which is going to be that guy, divide by open paren, and in this case, let's see, oh, I need the standard deviation. Oh, I need one other piece of information. I apologize. We got to calculate one more thing here. I need the standard deviation of all of those observations there. So in this case, I'm going to do an equals STDEV. That is the intrinsic built-in function to do standard deviation inside of Excel. Open paren, do an A:(A) again. That's going to select all of the values there. Don't do any rounding with that standard deviation in this case, because now we can do the corresponding t-value or t-statistic. Now we can start it out. So equals observed, which is that cell, minus the hypothesized mean, divide by, open parenthesis again, the standard deviation we just calculated, divided by the square root of the number of observations. Close the parenthesis. We end up with 0.092, etc. They want everything to be 3 decimal places. So I'm going to need to round this guy to 3 decimal places. So I'm going to come up here, do an equals round, comma 3, and I got 0.092. Next piece I'm going to need is the p-value, and I'll key all this in here in a minute. I'm just going to go ahead and do the p-value now at this point. To do a p-value, since we are dealing with a one-tailed relationship, is always 1 minus norm dist, and I'm going to use the t-value I just created, 0 for the mean, 1 for the standard deviation, and a true there. That's going to get me that value. Again, to 3 decimal places, I have to come up here, do a round, and to the end, do a comma 3. That's going to get me 0.463. All right, last piece of this, we need to determine whether we reject or fail to reject the null hypothesis. So I'm going to do a line here again. Level of significance is 0.05. And as we've talked about previously, anything greater than the p-value, we fail to reject the null hypothesis. If it's less than it, we reject it. So based upon, change the color here, there we go. We came up with a p-value of 0.463. So 0.463 is selected there. Hence, we're going to fail to reject, and there is not sufficient evidence. We said that earlier in the previous problem. When you reject a null hypothesis, there is sufficient evidence. When you fail to reject, there's not sufficient evidence. I think we got all the pieces that we need to key in. So our mean was that 2.752. Our t was our 0.092. Our p-value is 0.463. Since the p-value 0.463, it's greater than 0.05. So I'm going to select greater there. We are going to fail to reject, FTR, fail to reject, and there is insufficient evidence that it's greater than the 2.75. Let's check it, and everything's good there for the first problem. Okay, for the second part of this, they are telling us in the instructions to use sheet 4. I don't want to have to recalculate everything, and since the data inside of sheet 4 is already there, here's what I want to do. I'm going to highlight those guys, do a Control-C to copy, and I'm going to come over to sheet 4, paste this into cell C1. Let's make that a little bit bigger there so we can see what's going on. All right, now there is some changes that we got to do in this instance. The mean, if you notice, was already calculated, so I don't have to change anything there. The hypothesized mean is going to be off of what they gave you inside the problem. That does need to be changed to 11,000. The sample size they told you inside the problem is 45, so we're going to change that. And the standard deviation is already being calculated off of that particular guy right there. So let's see what else we got going on here. They wanted to 4 decimal places this time. So for this guy right here, we will need to change the formula slightly. So we're going to change that to 4. Notice you're going to have that there. And then the p-value, again, instructions tell us 4. So all we got to change that, instead of it being 3 decimal places, we're changing that to a value of 4. And now we've got our corresponding values there. All right. One additional thing we've got to identify. Let's get the number line going here again. Draw the number line. And in this case, they tell us level significance is 0.05. Again, anything to the right, we fail to reject. Over here, if it's less than it, we reject. Our corresponding p-value, right there, 7674. So 7674, we are in the fail to reject, and there is not sufficient evidence. If it would have been in the rejection region, there would have been that there is sufficient evidence. All right, so I think I got everything I need to do the calculation. X bar is going to be this value, and they want it to 4 decimal. Actually going to have to come back up here. Let's make sure we're rounding this accordingly. So let's see here. Number, we're going to increase that by 1. There we go. So we got 10,881,2341. T value negative 0.7304. And then the p value is 0.7674. P value is over here greater than the level of significance. We are going to fail to reject, and is insufficient or is not evidence for that. So if we check it, let's see what's going on. What did I miss here? 10,881,2341 negative greater, fails to reject. Oh, I didn't pick the histogram. This is I apologize, I missed this piece. Sample size is greater than 30 by central limit theorem, therefore yes. And let's see, what else am I missing here? It is greater, fails to be rejected, insufficient evidence. 10,881,2341 negative 0.7304. Oh, let's see what's going on with the corresponding p-value. Just a second here. I apologize. This is based off t-distribution. The previous problem is dealt off of normal distribution, so we have to change the calculation slightly here. So it's going to be equals t dot dist. And the first piece of t-distribution is going to be off of the t-value we just calculated. Degrees of freedom is always 1 less than the sample size. So I'm going to reference that and subtract 1 from it and make that a true. That's going to get me 0.2345 if I round. So let's come back up here, do the round on it, round, come over here, do that to 4 decimal places. We got 0.2345. So I'm not going to rework the problem, but this guy right here would have been keyed in as, get my pen going here. You would have keyed in 0.2345 to get the correct answer. Only thing that changes over here, we still, everything else that we did is correct on this one, but 0.2345 is already going to calculate that fail to reject region. So everything else we did, the greater than fails to be rejected, insufficient evidence, we still get the same result with the revised p-value. Completing problem number 2. For the third problem that's listed here, we'll go ahead and they want sheet 5 this time. Since they've already done majority of the calculations, I'm going to do a highlight those guys, do a Control C, come down here to sheet 5, come into cell C1 and paste those guys in. So now we've got our corresponding values there, round to 4 decimal places. First, for the mean, it's utilizing column A of sheet 5. So we've got that already keyed in there, good to go. Let's see here. Oh, let's just go ahead and do this one. They want sheet 5. This is for problem number 2. You'll just see the problem twice here. So 11,000, sample size is 45, significance level of 0.05. So we'll calculate our corresponding values. The average is 10,521.2914. T value there is the negative 3.7626, negative 3.726 or 7626. P value was calculated as 0.0002, and it is randomly sample size greater than 30, so we can select yes on that one. Let's analyze the reject or fail to reject this one. So level of significance is still 0.05. And then our p-value is sitting over here, 0.0002. This is our rejection region. This is our fail to reject region. So we will reject this time. When we reject, there is sufficient evidence in this instance. So let's go ahead, verify we did that correctly. So the p-value is less than it. We will reject it, and there is sufficient evidence in that case. So I think I got everything keyed in there, ready to go. Check it. Now we're good to go on that one. Now we can go to problem 3. Problem 3 wants us to use sheet 7. So if you can't see it fully on the screen, notice there's these toggle bars at the bottom. You can toggle accordingly over. So now I'm on sheet 7. You want to go back to sheet 5 here just for a second. I want to copy those values so I don't have to reinvent the wheel. So highlight all of those, do a Control C, come into sheet 7, select that C1, and now we've got our initial values there ready to go. First one only wants 3 decimal places. So if you come down to the number ribbon, we're going to decrease that down to 3. And our given hypothesis mean was given to us in the problem as the 40. We need to change that. Our sample size is 60 this time. And let's see here. Sample size is greater than 30. Central limit theorem allows me to select yes there. So now we've got our t value. Again, they want 3 decimal places, so you have to change the rounding accordingly to 3. And then if I come down here, that changes that to 3 as well. Let's see here. Now, we do got one minor little thing here for this particular problem. It tells us it's supposed to be 40 feet. However, for this particular problem, they're testing an equals, not equals relationship here. For that reason, the previous problems that we did were based upon having a one-tailed test. For a two-tailed test, we have to double the p-value because it exists. A rejection region exists both in the left tail and the right tail. For that reason, now we've got the correct p-value. So that formula had to be slightly modified to get to that value for this third problem because of the equal not equal relationship on that, guys. So let's analyze relative to whether we're going to reject or fail to reject. Easiest way is the visual here. Level of significance is 0.05. Anything to the left, we reject. Anything to the right, we fail to reject. Our p-value up here is 0.974, which means we fail to reject in this instance. So I think we got everything here. When we fail to reject, there is not sufficient evidence. So I think we got everything now. So our X bar, our mean, 39.965. Our t value, negative 0.033. P-value, 0.974. P-value is greater, we reject, and there is, it is not rejected, sorry, fails to be rejected, insufficient evidence. That's what I just said a second ago there. All right, so insufficient evidence, check the answer, and we're good to go. This completes the demonstration of week 5's challenge and participation activities from the ZyBook. Thanks.